Okay, now this is chapter 3 related to hardware. So it has different aspects of hardware. The first one is computer architecture. So basically, this is related to computer architecture. This tells how a computer works. Okay, so just wait a second. I explain it. Now see how basically computer works. I'm drawing. I'm going to basically whiteboard. Then I tell you the basic of this. Okay. Now, basically, it is talking about CPU. Remember, CPU, if we talk about this is CPU, okay? It has two parts. This is CPU means microprocessor. CPU has two parts. One is CU and second is ALU. Now, remember, CU is basically kind of director which give instructions to other parts. Other parts, we can say other parts, what to do. Okay, it tells every component of computer what to do, what kind of. And ALU basically perform execution, kind of that. Like if you give instruction C is equal to A plus B, addition of two number will be done by ALU, and assignment of this value to the C will be done by equal sign, and it is done by ALU. Now, CPU attached with one of the memory is cache. Cache attached with another kind of memory, that is RAM. This is RAM. All input devices data goes into RAM, remember. And output device shows data from RAM, like monitor. Data goes into RAM and output shows on by the RAM. This is like that. CPU also connected with RAM. Then you have a hard disk, secondary memory. Yes, cache is a memory. I tell you separately, but just see that cache is a kind of memory. So RAM is connected with hard disk. Okay. These are dotted line, which basically are control signals. As I told you, CU gives instruction to all component of computer and tells other parts of computer what to do. Okay. Whenever we give instruction or kind of data from input device, it goes into RAM. Remember, RAM, one portion is occupied by OS. OS is operating system. It is always loaded into RAM until computer or any device is in running mode. So whenever we give data, for giving data, we need to open any application like MS Word, Excel, any programming language, kind of any application we have to open for giving data to the computer. Okay, without application, we could not give data. So data goes into RAM. It holds in the RAM. So CPU picks data from RAM for processing purpose. Now see, remember, CPU always looks first cache, second, then looks on RAM. Is there any instruction? If there is no instruction found in cache memory, then it will check RAM. Okay, so it takes instruction from the RAM for processing purpose. If ALU can also directly connect with the RAM, so it can bypass the cache memory, because if it doesn't have any instruction on cache memory, So it will check in the RAM. CPU gives instruction to all component part to synchronize the operation. So make it. Now remember, each basically CU and ALU, they have own memory that is called register, which is come in the bytes. This is register. Got that? So this is the sequence. Instruction, data, and program are open in RAM. Now remember, instruction, data, and program, they reside in RAM. And CPU picks instruction from RAM, okay? Or from RAM to cache, cache to CPU. So again, coming from CPU to cache, cache to RAM, this thing. So you got it? Then I move to onward. Okay, I repeat it again. Now see, you have to give instruction from any kind of input device. So all data always comes from input device and it is held in RAM. So CPU picks data or instruction from RAM. Okay. So RAM is an intermediate device among all devices. And from RAM, data goes into cache, and from cache, instruction goes into CPU. Okay. But sometimes CPU can access directly RAM to get the instruction. Okay. If it doesn't found any instruction from cache, so it has happened. Okay. Now main thing is, okay, CPU has own internal memory. Remember, I'm writing here, CPU has own internal memory called register. It is in bytes, maybe 4 bytes, 8 byte, or 16 byte. Okay, register memory size comes in only bytes, 4 byte, 8 byte, and 16 byte. We also call it 4 byte means 32 bits, 8 byte means 64 bits, and a 16 byte means 128 bits. Remember, and we also determine the speed of computer by with the size of bits: 32-bit processor, 64-bit processor, 128-bit processor, so that computer can handle these number of bits at a time. Okay, got the idea? So I'm moving to next part. Should I move to next part? Okay. Okay. Yes, Nama, you got it? So I'm moving to next part of that topic. Okay. So I'm removing this one. Okay. I'm also showing another diagram so that you can understand basically, which comes in chapter 3 also: fetch, decode, and execute cycle. Now see here, this is your CPU. Again, it has two parts, CU and ALU. It has kind of memory, like memory, and we want to add two numbers like 6 plus 5, 11. Okay, remember the first stage of fetch decode cycle is fetch. Second is decode, and third is execute, and fourth is fetch, decode, execute, and fourth is store. Now what happened? CPU get instruction from memory This is the first stage. So you can write getting instruction from memory is called fetch. From memory is called fetch. This is the first step. Okay. Now after first step, decode. This is decode. Now remember, fetch and decode is done in CU part. It is done by CU. So decode means telling or interpreting, telling ALU or other part okay. So decode means, okay, I'm writing it again, sorry. Okay. Decode means interpreting or telling to other parts, means what to do. Like decode means CU will tell ALU add the two numbers. Okay. And addition of actual processing is done by ALU. Okay, like addition, subdivision, subtraction, multiply, and stress. And after producing the result always store. Now third step is execute, and fourth step is store. Result always is stored in accumulator. Accumulator is a kind of register. Okay, and then it's transferred to RAM also. This is the machine execute cycle. We also call machine execute cycle, fetch, decode, execute cycle also. Okay, is this clear? Yes, ma'am. So I'm moving to book part so that you can understand the rest of the topic. Okay. Now see, I'm opening book. And this thing, what we have discussed is this is called von Neumann architecture. Okay. Now just go through this paragraph, then ask me anything you want to discuss. Then I discuss again von Neumann architecture according to book. That was the basics which I have discussed. We also call CPU microprocessor. We also call it microchip. Okay. Now moving to rest part. Okay. This thing I already discussed. One thing I want to tell you about buses. Do you know about computer buses? It is electrical path. on which data, address, and instruction travels. Okay, wait. So remember, so I'm telling you, computer buses mean it is electrical path on which data, addresses, or instruction travels. So there are three types of buses. One is data bus, second is address bus, and third is control bus. So data moves on data bus, data moves on data bus. Address of data moves on address bus. Address of data. So moves on address bus. Signals, instructions moves on instruction or control bus. Okay. Now just go through this para from here to here. Then I tell you further. Just go through this para. So John von Neumann is the person who basically gives the concept of this computer architecture. That is why we call it von Neumann architecture in 1940. So first electronic computer was built on the basis of his idea. Here you can see these three steps. The concept of central processing unit. The CPU was able to access memory directly, as we have discussed. Computer memory could store program as well as data. Okay, stored program were made up of instruction which could be executed in sequential order. So instructions are transferred in sequence and they are processed in sequence. Okay. 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 This material is clear. Then moving to next diagram. Now see this diagram. They have given a sequence. Okay. There are some registers are given. One register, as I told you, accumulator. Okay. This is MAR. This is PC. This is MDR. This is CIR, and this is accumulator. 5 registers are given in your book. So first one is MAR, memory address register. MDR. Number 3, PC. Number 4, CIR, and number 5, accumulator. Okay, accumulator. So MAR basically here written is memory address register. Hold address of data, as I told you, address of data which is to be processed, which is to be processed. Address, hold address of that data which is to be processed. MDR. Okay, now remember, registers are small memory unit. Registers are small memory unit which exist in CPU. Registers are small memory unit. exist in CPU. Okay. Okay. MDR hold current data to be processed. PC hold address of next instruction. Address of next instruction to be processed. And CIR hold current instruction to be processed. Okay. And accumulator, as I told you, here I am writing. Accumulator hold result of data. Result of data. CPU always store result in accumulator, and from accumulator it transfer to RAM. Got the idea? Yes, Nama. Got the idea? So I'm moving to its next part. Okay. Now see. Okay. Before reading this, I just now you have to see basically see this diagram. Okay. Now how CPU basically works? It checks. Is there any instruction? Yes. The program counter contains the address of memory location of the next instruction which has to be fetched, as I told you. So fetch is the first stage. Okay. Getting instruction from memory is called fetch. This is the first step. Let's say the program counter contains address of the memory location of the next instruction which has to be fetched. Okay. Now remember, then what happened? The address is then copied from the program counter to the memory address register MAR. This is done using the address bus. Okay. So address bus will carry the address of data which has to be processed. The third step, the content instruction at the memory location address contained in MAR are then copied temporarily into the memory data register MDR. The MDR will have a data, okay, and its data, its address will be held by MAR. This is MAR. Now the fourth step, the content or instruction of MDR are then copied and placed into the current instruction list. So from PC data transfer to CIR instruction. So the value in the PC is then incremented by 1 so that it now point to the next instruction which has to be fetched. So PC is updated. PC like this, PC plus 1, because it has transferred its instruction to CIR. So it has transferred instruction to CIR. So CIR will hold current instruction on which processor will work out. Okay. The value it has been updated. The instruction finally okay. The instruction is finally decoded and then executed. Now decoded, second stage, if you remember, decoded. I remember CU perform fetch and decoded operation. ALU perform execution. The instruction is finally decoded and then executed by sending out signal via the control bus to the various components of the computer system, so that all components must be ready to perform current operation. When it is completed, any more instruction to service? Yes, this process start again. If no, then it will end. Okay, you got the idea how basically different registers are working together. Like the first part is PC, PC transfer data to MAR. Okay. Then MAR basically MAR pass the address of data, okay, to MDR. From MDR, it will transfer to CIR. Okay. This is kind of process how information is passed on from one register to next register. Yes, now I got the idea. Yes, Nama. Okay. So I am moving back so that we go through. Now see here diagram. So you can see that control bus is connected with control unit. It has system clock. Then it has CU connected with ALU, and this CU connected with program counter. Okay, because it has given instruction to program counter. As I told you, program counter will have a next address of next instruction to be fetched. Control unit also connected with memory address, MAR. Okay, and then CIR also connected with CU. Accumulator is connected with basically ALU. So accumulator also gives input to the ALU and also take result produced by ALU. It hold in accumulator. Then it has MDR. It is connected with MDR, and database hold data and MDR, and this data will be held in MDR register. This is also connected with CIR. Now first go through material so that you can understand further. Okay. Now first go through this para, the ALU. These are operation of ALU, plus, minus, shifting, or logic, example and or operation to be carried out with a program while program is being run. Yes, synchronization means it makes prepared every part of computer to perform an operation, okay, of data flow and program instruction throughout the computer. So have you read? Okay, good. So see you its next part. Now see this one. Okay, the purpose of system clock basically purpose of system clock is used to produce timing signal on the control bus to ensure that vital synchronization take place. Means every part of computer need to be ready to perform a specific task so that everybody knows at which time operation will be performed. So without the clock, the computer would simply crash. We also call RAM immediate access store because it is between all parts of the computer. Yes, Sam, are you going through? Are you reading? Okay. If you have any problem, we can discuss. Okay, after reading this, we can end the class. Okay. Go through this table. Have you gone through table? Okay. So see you in next class. See you in next class. Okay, Allah Hafiz. Try to be regular. Okay. So that you can cover your most of the topic. Okay, Allah Hafiz.